Hello and welcome back to a new episode of the series Crazy Stuff. In the last episode, I demonstrated my generic selection screen, which was implemented using the MVC pattern. For today's episode, I added a screen controller to the existing pattern. What do I need a screen controller for, or what is it anyway? The screen controller in my projects allows me to develop all my visualizations using screens as well as the further user interactions in an object-oriented way. This means that for each screen or subscreen I have a separate class with a predefined superclass with which I manage the display. These configurations are set at the beginning through a customizing table. In our already existing controller object, we now find the method call, which will be called after initialization, within the modules before output and after input of the application. There are new additional events for reading and writing as well as validating data using predefined customer-specific model classes for each screen, which are also defined within the customizing configuration. The initialized model class can be addressed by the customer within a redefinition of the following marked methods. Let's take a quick look at the program and see what has changed. First, we have a new screen and two subscreens for displaying the ALV and tree tabs. On the other hand, we have two new includes for the preparation of the view as well as the interaction with the end user. Within these two includes the method call from the controller class is called. Let's run the program and see what our screen looks like. All datasets are determined by a separate model class for the screen. The main reason for the implementation of a screen controller is the subsequent simplified development of Dynpro as well as UI5 application. Let's take another quick look at the customizing settings. For each screen, a customer-specific handler is defined as well as a model class for the preparation of the data. As you can see here, the same model class can be chosen for different screens. An overlapping use can be, but does not have to be. Let's dive into the development of the screen controller. The initial point is, as already mentioned, the method call. As a first step, we need to determine our screen configurations from the parent model instance. The screen class, which is instantiated on line 30, then allows us to make customer-specific developments within the defined Z class. This is due to the fact that each program has to fulfill different criteria during preparation, as well as each program has different functions available. After reading the screen configurations, we need the data from the selection screen for a subsequent determination of the output data. We now instantiate our model class to our screen. First, of course, we must check that this class also has the necessary superclass. After the check, the instantiation takes place, where we can pass our selection data, so that these can be used in the model class for selection restrictions. After checking an instantiation, we can now jump to the presenter class using the following event and start our screen processing. The events for reading, writing, and validating data that are required for jumping to the model class are now registered here. The selection data is optionally passed here to the PBO module for possible user checks. Here we are at the point where the custom class for screen processing is called. Now, for example, the title as well as the status for the function buttons can be defined for the program. All user interactions to function buttons as well as to tab strip control can now also be handled class-based. In the further process, all defined screen classes for the individual screens and subscreens are now called and processed as in the usual process. We will now turn our attention to the instantiation of the Alv Grid within screen 101. Within the superclass for the screen controller exists the marked function, which allows a simple and efficient integration of the Alv Grid. Here, too, a customer-specific class can be used to redefine the desired methods of the superclass and breathe life into them. Let's now take a look into reading the model data for the Alv Grid. Before we jump into the method for preparing the data, here is a short overview of the grid class. In the future, the events like on double-click or on-click will be available here as well. And now continue reading the data. To jump to our model class, we trigger one of the defined events, in our case for reading an internal table. By passing a reference for the parameter, IR data, we are able to get the values from the model without a returning or importing parameter. With the triggering, we jump all the way back over the presenter into the custom controller class in which the method for reading has been redefined and the desired model call can be made. The model object corresponds to the class that was defined at the beginning in the customizing setting. The following is a brief insight into the model class in which we determine the general material information for the display in the Alv Grid. After the successful processing and display of the data, we close the presentation by thanking you for your time and saying goodbye until next time.